So in this video, I'm going to look at some tricks to evaluate determinants. So I've got two examples here. So I'm assuming you know how to evaluate a determinant, but maybe you could just see a few more examples with tricks. So I have this 3 by 3 determinant, and then I have this, what is this, 1, 2, 3, 4, 5, 1, 2, yeah, 5 by 5. Okay, so first of all, vibe check. So a 3 by 3 determinant is a very different vibe in my head than a 5 by 5. So a 3 by 3 is at least small enough that I can still kind of brute force it if I need to. But ideally, I would like to evaluate it in a smart manner. A 5 by 5 determinant, I am not going to brute force that. That would be just crazy, because inevitably, the reason why I say it's crazy is it's just like, it's so much work to actually get to that. So like, these are kind of two very different situations, and I just wanted to call that out right away. Because this, okay, like I said, brute force if needed. This, we are not brute forcing this. We are going to use any other trick we can, because we're just so likely to make a mistake otherwise. So let's just go into both of these now. So starting with the first one, so this is just a little 3 by 3 here. So ideally what you're looking for is you're looking to evaluate wherever there's a 0. So in this case, this one is kind of written a little strategically, because I've got these two zeros here. So I would like to evaluate the determinant along this row. Now, the other thing that I think is always handy is, like, so when you are coming up with your determinants, I always just think of like the signs for my determinants. It looks like this. So depending on, so these are like the signs that you're going to use, whether or not you add or subtract, like your minors, I guess is the word that I'm looking for here. So this is kind of a cheat sheet. I don't actually really think about like, oh, what minors am I using? I kind of just look at the pattern, and then I use this pattern to help me figure out kind of what I need to do with the math. Okay, so that's the first thing that I wanted to say. So the thing that's really clear then is if I expand along this row, the benefit is that if I were to expand along 0, so remember what happens with these, right? So I'll get rid of this for a second just so we can talk about this. Okay, so if I wanted to like start by the calculations involved with 0, so what you end up doing is you cross out the row and the column. And so ultimately what this would be is 0 times, and then I've got this 1, -3, 1, and 3. So it doesn't even matter what this calculation is, because I'm multiplying it by 0. So that's why we want to expand along the zeros, because it just makes our lives a lot easier. So then I can get rid of all this stuff. Let's see, one sec. Okay, I've got everything reset. So yeah, so this 0 and this 0, the calculations just fall out. So the only thing I have to do then is think about the 2 here. So I'm just going to cancel out the column and the row. And then, okay, so this little like pattern, this little chart is going to ultimately be the sign that I want to put in front of the 2. So in this case, this is going to be a negative. So I'm going to start this off as -2, and then times these other entries that are left over. So these other entries that are left over, this is 2, 1, -2, and 1. So let's see. If I go ahead now and calculate this determinant, this ends up becoming, so this is 2 times 1 minus -2 times 1. So that's going to be -2 times 2 plus 2. So that's going to be -2 times 4. So that's going to equal -8. And so that will be my determinant, and I don't have to do any of the other work. So the first trick with determinants is to stay really efficient with them. Leverage any zeros that you have. Okay, now let's go to the other one, the insane one. So there's a lot of different tricks you can use with determinants. But I do want to like kind of blow out the reasoning with this. So at first glance, so I do see a lot of zeros in here, and you might think to yourself, oh, I'll just expand along this row. But in the case of a 5 by 5 matrix, that is still crazy, because so what I ultimately end up having to do is I take -2, and then all of this stuff here, so I'll just write it down just to make it clear. Okay, so all of this stuff here, this is now, just to be clear, this is the determinant that I still have to find. This is still a lot of work, right? So I just don't want to go this route. I want to do anything I can to avoid that, because the more numbers and determinants you have on each other, it just gets harder and harder. So I want to think smart about this. So let me clear this out. And at this point, it's kind of important to know your determinant properties. And the determinant property that is just popping out at me here is, so determinants that are in a triangular form. So a triangular form means that you have numbers down the diagonal and then either all zeros below or all zeros above. So when a matrix is in that form, then you can just multiply the diagonal entries down, and that's the determinant. You don't have to do any other work. And that's really what I want to use here. I want something that's not going to have any other work, because if I have to start finding subdeterminants or little, minors or all that other stuff, it's just nasty and it's too many numbers, and I'm probably going to make a sign error. So we're not about that life. All right, so looking at this, so let's just be nice and clear for a second. So down here, those are all the diagonal entries, okay? So really, the problem points right now are, I would really like for this to be a 0, and I would really like for this to be a 0. If those are both zeros, then I can use the little property with my triangular determinants or triangular matrices, finding the determinants of them, and then I can just multiply all these things together. So the main row operation that you want to use is going to be the row operation where we want to multiply a row times a constant and add it to another row. So the reason why we want to do this is that this particular row operation does not impact the value of the determinant. Any other row operations will mess with the value of the determinant. So we want to specifically use this one. So we're just kind of being strategic about this. And so thankfully, actually, I can use these row operations no problem. So there's 2 row operations that I want to use. So first of all, I would like this to be a 0. And I notice that I can easily do that. So I don't have to go into, I don't have to make everything this big row echelon form. I know that we have an algorithm for that. But in this particular instance, I notice that if I just take -2 times row 1 plus row 2, I just need this to be a 0. I don't really care what's going on here. So just in the context of this particular problem, yes, I could do all this work to, get this in row echelon form, but that's not, I'm just told that I just need to evaluate the determinant. And if that's all I have to do, then I'm not going to go through the work of turning this into a 1. I'm just going to go through the work of turning this into a 0 because that's easy. And then remember, the other entry was this 2. So I want this to also be a 0. And again, I can easily do that. So I can use this one here to turn this into a 0. So this can be -2 times row, let's see, what is that, times row 3, and then I'm going to add that to row 4. So those are the 2 row operations that I'm going to do, and if I do these 2 row operations, it's not going to impact the value of the determinant. So you just want to be strategic about this. And I know sometimes you'll have books or you'll have all these different processes of oh, I got to do it in row echelon form, but context really matters. And if you're not told that you don't have to do anything with row echelon form, then let's not do it. So, let's see. All right, so I'm just going to, for the interest of time, write out row 1. And then let's see if I do the math here. Let's see, this will be 0. This will be -2. This will be -9. This will be 3. And this will be -7. And then I'll write down the next row. And then, let's see, we need to do this other row operation. So this will now be a 0. Let's see, -2 times 3 is -6. -6 plus -3 is -9. And then let's see, this will be -3. And then I'll just write down the last row. Okay, so it's hard to squeeze everything onto the page, but there we go. So now I have just these entries on the diagonal. And so I know from my determinant properties that if I have a matrix in upper or lower triangular form, I can just multiply these together to get my determinant. So my determinant then is just going to be 3 times -2 times 1 times negative 9 times negative 2. And if I get up my fingers and toes and multiply this together, I get negative 108. And so that's going to be the determinant. And I don't have to do any other work. So, you know, it's just really important to kind of think about what situation you're working with, and also think about what makes sense. I know sometimes, you know, books or lectures or whatever, they talk about, oh, we got to do things in this way. But then when we're just asked to evaluate, we do have a little bit of creativity. So, you know, I don't have to put this exactly into that perfect row echelon form. And it would suck to do so because I would have to like divide this row by 3, and you can see that not everything's going to divide by 3. So I'd really like to avoid that as much as possible. So, all right, that's it for this video. Hopefully that gives you some ideas of things to try out. If you found that helpful, I'd love it if you hit that like or subscribe button. And otherwise, I'll talk to you guys in the next video. Bye!